Hey everyone, this is a short video demoing how we use Envoy proxy and a WASM filter to make requests to an open AI API and parse a response to get some metrics from them, expose them in a Prometheus endpoint and visualize them in Grafana. So here's what this setup looks like. This is a local kind cluster. I have an Istio gateway and we have a HTTP route, and that proxies on to an OpenAI API. Now that's actually a mock endpoint that OpenAI provides, just for simplicity instead of running an LLM. We also have a WASM plugin resource that's an Istio resource. So I'm using Istio here just for simplicity, but we could go lower to Envoy proxy here if we wanted. In the second diagram below, this is how it is implemented. So we do have Envoy proxy under the hood, and the WASM filter will be intercepting requests. It'll be intercepting responses actually, and we expose the Prometheus metrics from Envoy proxy on the stat/Prometheus endpoint, and then we visualize them in Grafana. So here's what the gateway looks like. So the gateway has a single listener, and we have a single HTTP route as well. So this will send on requests to this external host name and do some URL rewriting on the host name as well to make sure that it knows what host it goes to on the other side. We're also going from port 80 here onto port 443. That's so we can do the response parsing without having to worry about TLS. This is the mock OpenAI API. So it provides the chat completions endpoint, and you can send a bunch of different data to it. We're just going to send a simple request, and we know what to expect in that response. The main thing we're looking for in the response is this usage block that shows the number of prompt tokens used for that request and completion tokens and the total tokens overall. So as these values come back in responses, we'll be incrementing 3 different metrics with those values, and those are what are exposed through the Prometheus endpoint. So here's a little bit of what the WASM filter looks like. So we are, if we scroll up a little bit, we are intercepting the response body. We're doing some buffering here as well. Make sure we get the entire request first so that we can parse the JSON. If we scroll down here, we can see if we do have the usage data in the response, we'll increment those 3 different metrics that we showed. So the name of the 3 metrics, they're initialized up at the top here. So we have my WASM prompt tokens, completion tokens, and total tokens. So I have all this deployed locally, so it should look like the bottom diagram in my local kind cluster here. I've already made some requests as well, so I have sample data up and running. So I do that with this curl command up here. So we're just sending it an example string, and it will respond with the exact same response every single time. So if I scroll down here, we'll see that response here. But if we look a little closer here, we'll see the usage block here with the number of prompt tokens, completion tokens, and total tokens used. So that's what gets parsed out by the WASM filter and incremented in the metrics. So if I jump over to Prometheus now, we're already scraping the Prometheus endpoint. If I jump over to Prometheus and execute this query here, I'm just looking for any metrics that begin with my_WASM. I can see the 3 different metrics here with values. I can graph them here as well if I want. So they're counters, so they're always going to be incrementing. And then I have a small dashboard as well that shows the rate of token usage as well. So I'll jump over to that. So we have 3 different panels here for 3 different metrics. Now they all look the same because it's all sample data. We have the rate of token usage here for completions and for prompts, and the total, which is the combination of the two of them.